So after knowing the speed, let's come on to the types of problem. And the first type of problem that I get here is hands of the clock coincide. Okay, so now I'm telling you that it is 4 o'clock in the watch. So my hour hand is here at 4 and my minute hand is here at 12. Okay, so I told you it is 4 o'clock in the watch. What am I asking you right now? First thing, what is the angle between the hour hand and the minute hand right now? It is 4 o'clock. So what is this angle? This green one, that will be equal to 120 degree. Right? That is quite simple. Why? Because between 1 hour the angle is 30 degrees. So it is 4 hour. 30 into 4, 120. We know that. Now I am asking you question is, it's 4 o'clock between 4 to 5. Which means in this 1 hour between 4 to 5, at what time will the two hands of the clock will coincide? So between 4 to 5, at what time will the two hands of the clock will coincide? First of all, what is the meaning of coincide? Say this is my hour hand and this is the minute hand. They overlap. They overlap like this. Okay, this is the meaning of coincide. When will this happen? What is the time during that time when this will happen? Okay, 420, 421, 422. Let's see. Let's analyze this even better. Now I am saying that let this hour hand be stationary. Okay, if it is stationary, what is the meaning of this? It cannot move. Okay, it cannot move, so it is stationary. Now if this is stationary, what time, when will this happen now? If the hour hand is stationary, at what time will this minute hand coincide with this hour hand? If consider the hour hand is stationary. So what is the speed of my minute hand? 6 degrees per minute. So it will go 6 degree in 1 minute. Now it has to cover what? It has to cover 120 degree, right? If this minute hand covers this 120 degree, it will come and overlap over this hour hand, something like this. And I can say they can coincide. So the distance that the minute hand is supposed to cover is 120 degree. The speed that it has is nothing but it goes 6 degrees per minute. In 1 minute it goes 6 degree. So to cover a distance of 120 degree, can you tell me how much of time will be required? So time is equals to what? Time is equals to distance upon speed. Distance that the minute hand is supposed to cover is 120. Speed at which it is going is 6 degrees per minute. So what is the time that will be required? If I do 120 upon 6, the answer is nothing but 20 minutes. So in 20 minutes this minute hand will coincide with the hour hand. So it is already 4 o'clock. If you add 20 to that, at 4:20 the two hands of the clock will coincide, and that is my answer. Okay, but what is the problem here? I considered the hour hand to be stationary. That is when the answer came to be as 4:20. So when is the answer 4:20? In 20 minutes the minute hand will overlap over hour hand, given the fact that hour hand is stationary. But we know that hour hand is not stationary. Okay, hour hand is not stationary. It is also moving, and we know the speed of hour hand. What is the speed of hour hand? Half degrees per minute, right? We had just find this out in the previous section. So now what is happening? Again I am asking you this time only. This time only I am writing it here. Time is equals to what? Distance. Distance that minute hand is supposed to cover is 120. This is all good here till now. Okay, now I need to find it out. What is the speed at which this minute hand is traveling? It is not traveling at the speed of 6 degree per minute. That is the speed of minute hand. But what is the relative speed I am asking you? What is the relative speed of minute hand? That is not 6 degree per minute. Why? Because when minute hand is traveling by 6 degree, the hour hand is also traveling ahead by half degree. So eventually resultant, how much did the minute hand travel? It traveled only 5.5 degrees per minute. Because if it traveled by 6 degrees in 1 minute, it went ahead by 6 degrees in 1 minute, the hour hand also moved ahead by half degree. Okay, and the job of minute hand is to catch the hour hand. So how much of distance did the minute hand covered in 1 minute to catch the hour hand? It covered only 5.5 degrees. It covered only 5.5 degrees. Okay, that's why instead of this 6, I'll write it here as 5.5. because it is covering only this much of degree in 1 minute. Okay, when I am thinking of minute hand chasing the r hand, right? Because here the concept is just simple. Minute hand has to chase r hand and catch the r hand, okay, such that it will overlap over that. So in that respect, the relative speed is 5.5 degrees per minute. So now if it goes 5.5 degrees in 1 minute, how much of time will be required to travel? 120. Okay, so instead of 5.5, I'll write this as 11 by 2, okay, because I want to make calculation easier, and I'll keep this as 120. Now take this 2 to the top, so 120 into 2, this turns out to be as 240 by 11. Now just solve this. This is 11 2s are 22, 20, 11 1s are 11, 21 9 by 11. Okay, that's what I get it from here. So this is my 21 minutes. It is not 420. It is not 420. It is 4. It is 4, then 21 minutes. Okay, and 9 by 11 of the 22nd minute. So if it would have been 11 by 11, it would have been 1, right? Which means the 22nd minute. So it is 9 by 11 part of the 22nd minute, not the complete 22nd minute. So how many seconds are there in 1 minute? 60, which means 9 by 11 of 60 seconds. I'm converting this to seconds now. So 4 are 21 minute, okay, not the complete 22nd minute. So how many seconds of the 22nd minutes? So 9 into 6 is nothing but this is 540 divided by 11. So this becomes what? 11 4s are 44, 10 100 9s are. So that's my final answer now. 4 hour 21 minutes 49 seconds is when the two hands of the clock will coincide. Okay, that's your final answer. So not 420, because the r hand is not stationary, it is also moving. Now imagine a scenario. Actually what is happening here? Okay, let's put it as a scenario here. So I got my final answer as 4 hour 21 minutes and 49 seconds when the two hands of the clock will coincide. What and how it will actually happen? So it is 4 o'clock, so my r hand is here and my minute hand is here. What will happen at 4:20? At 4:20 this minute hand would have come here and it would have been at a position of 4, but in that 20 minutes r hand would have slightly moved ahead. Okay, this is the scenario at 4:20. What will happen at in the next 1 minute 49 second? This red hand will move from 4 to ahead, and at 4 hour 21 minutes 49 second it will overlap with the r hand, and minute hand and r hand will overlap or coincide at 4 hour 21 minutes 49 second, and that is my final answer to this. Okay, so that's a simple concept. All that we did it here is time is equals to distance upon speed. What is the distance? Distance is being always traveled by whom? The minute hand. Why? Because the minute hand here is chasing your r hand. Okay, so distance is always traveled by the minute hand, and this is the speed that you write is always the relative speed. Okay, it is always the relative speed of whom? Relative speed of minute hand.